Newton's method is it's an application of the derivative, specifically the equation of the tangent line. What it does is it numerically solves equations f of x equals 0. It finds roots of equations using this iterative method. Okay, let's learn by example. Say I'm trying to solve the equation x plus 2 equals x cubed. The first thing I need to do is bring everything over to one side so it's written as something equals 0. So I'm going to write it as x cubed minus x minus 2 is equal to 0. And that means the function that I'm trying to find the roots of, or of which I'm trying to find the roots, is that polynomial. So I'm going to plug the function in there. I need its derivative to plug in the bottom here, so let's get its derivative. F prime that's going to be 3x squared minus 1. And so I've got the function to plug in. So let's get our formula together here. So our function that we're trying to find the roots of goes on the top. The derivative goes on the bottom. And all of these x's in here are all x of n. When I plug in, I need to choose a starting value. I'm going to choose 1. So I'm going to make all these x's equal to 1, and that's going to give me my next value. So I'm choosing x subscript 1 is equal to 1. So the first value is equal to 1. That means the second value is, I need to make all of these values 1. It's going to be 1 cubed minus 1, 3 times 1 squared. And when I clean this up, this should be equal to 2. So if x1 is 1, then x2 is 2, then I have to plug 2 in. So I plug 2 in this equation, get a value, take that value, put in, get a number. This is going to be way easier with a spreadsheet. So here's a spreadsheet. This is my starting value of 1. This is the 2 where I take the number minus the function with the number plugged in divided by the derivative with that number plugged in. And that was equal to 2. I make 2 the next number. Here's plugging 2 in, I get 1.636. 1.63, I plug in, get 1.53, etc. So when I do that, it eventually approaches an equilibrium value. It looks like I'm getting the value 1.521. Okay, what's that? 1.52138. So if I were to take 1.5138, what was it? I forgot. 1.52138. 1.52138 plus 2. So I plugged it into here and I got, 3.5. So, and let's do this value cubed. Yeah, I'm getting 3.52. So if I plug in that 1.52 into this side, I get the same thing as I plug it in that side equation. I've solved the equation using Newton's method.